All right, today we are on the second part, the B part of section 3.2. Remember, we started by converting exponential form to logarithmic form and vice versa. Today we're also going to look at some graphs. I'm going to do some of the graphs by hand. Of course, you can use your calculator, help you with some parts of it too. We'll kind of mix and match here a little bit. So, food for thought. Without a calculator, simplify log base 2 of. So we would have to come up, of course, with the base, and the argument would have to be the same value. So the question is, what is the exponent on 2 that would equal -4? Well, you might think, oh, 2 squared. That's 4. That's not going to do it. 2 to the -2 won't work either because that goes into a fraction form. So there is no way we can have a negative argument. I can't come up with an exponent that's going to calculate out to a negative value. This, of course, is not possible. If you do try to type that in your calculators, it will give you an error message. Now, in the last section, we typed in log, just the log key, log base 10. I'm going to show you today how you can type in some other bases also, and you probably remember from last year too. So today we're going to take a look more so at the graphs of logarithmic functions. So again, let's just practice, because remember, a log is really an exponent. So I'm going to convert into exponential form. So we start with the base to the opposite side equals your argument. That is a true equation. 6 to the third power is 216. Same thing here. I'm going to start with the base to the opposite side equals the argument. And that is a true equation because 2 to the -1 would convert to a fraction form. So let's just take a look at the graphs here for a quick second. Graphing logarithmic functions. Remember, we did our exponent function, blue curves here on the slide in the previous lesson, section 3.1. Today we're going to convert them into logs. Red parts of the graphs. Very similar. The curves are just kind of opposite. They always reflect over this dashed line going through the middle of the graph, our identity function. And of course, what I'm going to do, because I can't do a log in my head, I can't do log base 5 or whatever in my head, but I can do exponents in my head. So I'm going to put them in exponential form and make a T-chart. Yes, I know your calculator can do logs and other bases. I will show you in your calculator, but for a quiz or test, it's going to require exponential form, just like it says on here. So first, let's put it in exponential form. So I like to think if we're in function form, h of x, just think of that. I like it y equals, especially when I'm graphing x, y. So I'm going to get it into exponential form first. So the base to the opposite side equals our argument. And I'm going to go ahead and add 3 over. Remember, this is the inverse of exponential. So we're not solving for y, we're solving for x. So I'm going to rewrite that 4 to the y plus 3 equals x. So there's my exponential form. I'm going to fill that in on the line. I'm just going to put the x equals first. You cannot combine the 4 and the 3 and make it 7 to the y. They're not like terms. Now, let's get the graph going, and then we'll answer some of these other questions. I'm just going to make a T-chart. Now, this time our exponent is y, so I'm going to put values in for the exponent y. So I'm going to start with something easy, 0. 4 to the 0 would be 1, 1 plus 3. Let's plot that, 1, 2, 3, 4. There's also my x-intercept on the x-axis. I might as well fill that in. Okay, let's put another nice, easy, small number in for our power, which I'm going to go 1. 4 to the first, 4. 4 plus 3, 7. I'm a little worried about putting 2 in, because 4 squared would be 16, plus 3, 19. I'm going to be way off the graph. So let's try some negative numbers. I'm going to try -1. So 4 to the -1, remember, is a fraction, 1/4. Then I have to add 3 to that, so I'm going to be at 3 1/4. I'm going to estimate it best I can. You've all seen my drawing skills. Okay, let's try -2. 4 to the -2 would be 1 over 4 squared. And then I have to add 3 to that. 3 1/16. Okay, I'm just a little past 16. Okay, so I'm going to draw it. So we're going to stay on the right side of 3. We'll just keep getting 3 and smaller fractions that are going to be impossible for me to graph on here accurately. So that also tells us our vertical asymptote. We're going to get close to 3, but we'll never actually hit 3 or cross it. So this dashed blue line is my vertical asymptote. And of course, now we can take a look at our domain. We are on the right side of 3. Our graph, our green piece of the graph is on the right of 3. So of course, my domain, I'm going to say all real numbers. x is greater than 3. Notice I didn't say equal to 3, greater than 3. We're on the right side of 3. We're never actually going to land on 3. Now, just some other little pro tips. One way you can also tell your domain and your vertical asymptote, yes, are always related to each other. I could tell you the domain just from the equation. Remember we talked about this in that first little question I asked you. Log base, what was it? Log base 2 at 4 to the negative 2. So I'm going to take my argument. We can never have a negative argument. It has to be over 0. So I knew it was be greater than 3. I knew that was also going then to be my asymptote because I would stay on the right side of 3. So that's another way you can tell from your equation. All right, same thing. Let's first get it in the exponential form and then we'll go through and make our graph. So I'm going to first, to get it in exponential form, we need the log isolated. So I'm going to subtract 2 over, so y minus 2. I also don't like the negative sign in front of the log, so I'm going to switch all the signs. Now I'm ready to convert it. The base to the opposite side, so my exponent's negative y plus 2 equals our argument. So I'm going to fill that in my exponential form. We'll make the t-chart, we'll do all of that good stuff. Now, I'm going to kind of do a little out of order here. Let's go ahead and see if we can find our domain and then, of course, our asymptote. My argument, of course, notice is just x. There's not parentheses, so just x. So that can never be negative, so it's got to be over 0. So I know that's the type of numbers we're going to end up in our function. That's also going to be my vertical asymptote. That's going to be my boundary line we'll never ever touch or cross. You'll see it when we get our graph going. Now, same thing. Y is in our exponent, so I'm putting numbers in for y. So let's pick nice, easy numbers. We can start with 0. 3 to the negative 0 plus 2. Negative 0 plus 2. Negative 0. I'm just going to put 0. So I'm going to end up with 3 squared, 9. That is also my x-intercept, so I might as well throw that on the blank while I'm here. All right, let's put 1 in. So I'm going to have 3 to the negative 1 plus 2. Negative 1 plus 2, of course, 1. 3 to the first. So 3 comma 1, that's not too bad of a point. So we can see our curves kind of going opposite of our last one. Okay, let's try 2. So 3, negative 2 plus 2. Negative 2 plus 2 would be 0. Anything to the 0 power 1. All right, let's try a negative number just for fun. Let's try a negative 1. So 3, negative, negative. Oh, I'm worried about this. Because the negative, negative 1 is going to be positive 1 plus 2. We have 3 to the third, 27. I can't graph 27, negative 1. Let's get real about that. So I think we probably have enough to see our curve here. Let's connect these. Now remember, we are on our domain is to the right of 0. So I'm never actually going to cross or touch the x-axis because that is my vertical asymptote. We're never going to cross or touch. So I am a little careful how I draw that. We've all seen my drawing skills though, so no judgment. Now, I'm going to show you, of course, in your calculator. Some of you probably already know this. You can type these in your calculator, the different bases. One thing, though, like I said, on class is going to ask you for exponential form. If you want to do like log base 3 of x, if you hit alpha y equals, I'm going to right arrow to function, that log base, number 5. Notice that pulls up. I could make that a 3, and then, of course, an x, and I could type in whatever else I wanted to type in. So alpha y equals, I'm just going to clear this out and show it to you again. So I'm actually going to type in this real function. So alpha y equals, I'm going to go over to function, log base is number 5, and I'm just going to type in 3x. Now don't put the plus 2 in there. We don't have parentheses around the whole expression. That is separate. Hit graph. Oh, Now again, remember, you know I love to complain about Texas Instruments. Don't let this graph mislead you. Notice my green curve keeps rising. It does. It should. So again, it's a curve that's continuous. It goes on in both directions forever. So don't just stop on the blue like your graphing calculator is showing you that display. You gotta be smarter than a calculator. All right, write the logarithmic equation in exponential form. So we've done this. We're converting between the two forms. This time, of course, we're in an ln. Now, if it helps you, ln, remember, is technically a log base e. We just never write log base e. We use ln. So that is the same thing. So I'm going to convert it. Our base, which is e, raised to the opposite side, that crazy decimal. equals 4. So again, I don't care if you rewrite your original function log base e. I'm just pointing that out to you. So same thing here. I just know ln is a base of e. So I'm going to do e to the opposite side equals our argument. And of course, these are equivalent equations. Once again, if it helps, you could have rewritten this. The ln is log base e. And then convert it. Base to the opposite side equals your argument. Same thing. All right, let's take a look at this. Write the exponential equation in log form. And of course, they give you a very lovely example. So again, log, our base would be e. The 0 and 1 are going to switch sides. Now again, we never leave log base e. We rewrite that as ln. And of course, some of you can skip that middle red line I wrote and go right to the answer. Totally fine. I'm just going to set them up for you. Same thing on this. Log form. So I'm going to just do log. I'm going to have 1 over, of course, e to the 4th. Now you could, this 1 over e to the 4th, I would think of that as e to the negative 4th. Because we need an exponent. We need to be in exponential form. So I'm going to rewrite this log base e, lovely crazy decimal, equals our exponent. So a little trickier this time because we need it to be in exponential form. I need an exponent of some sort. Log base e, let's rewrite as ln. And that is a true equation. If you type in your calculator the ln of that decimal, it will turn out to be negative 4. So just be careful on your e's. Make sure your original equation, this guy, write that as an exponent form, e to the negative 4th. We got to start in exponential form. All right, use properties of natural logs to rewrite the expression. So we're simplifying using your properties. Well, ln and b cancel out to the power. Technically, it's a 1 on the e to the first, so negative 1. ln and e, same thing, cancel out. Recognize that's really product between them. So you have 7 times 0. ln and e cancel each other out. I like those, no word. Nobody gets those wrong. All right, last problem of the day, a little word problem for you. Use the model, that very lovely fraction, which approximates the length of a home mortgage of $120,000 at 10% in terms of the monthly payment. In the model, T is the length of the mortgage in years, X is the monthly payment in dollars. Use the model to approximate the length of a home mortgage, $20,000, 10%, that has a monthly payment. So we're going to use 1167.41 as X. Now don't let the 120,000 and 10%, that data throw you off. That is, of course, just referencing the formula. They made the formula for those values specifically. We do not have to do anything with it. So I'm going to have T equals 5.315 over plus the ln of our monthly payment. For our monthly payment, we're using 1167.41. So all I have to do is type that into my calculator now. So here we go, 5.315 divided by, I'm going to put parentheses around the denominator because we have two terms, multiple terms there, 6.7968 plus the ln. ln's right there to the left of 4, 1167.41 cents. I'm going to close up my ln, and then I'm going to close up the overall parentheses for the denominator. Enter. So let's round that. Let's say that's approximately a 20-year span. Got it. Not too bad at all. So make sure on your graphs you can write those in exponential. Have a great day. Careful typing.